Hello, so in this video we will talk a bit more on the intro to radiation. We talked a bit on it from heat transfer, and so radiation is an incredibly interesting topic in of itself. It goes into a lot of deeper areas of physics, and so I'm going to begin the process of just kind of learning more about it. So first we're going to go what is, from, and characterize, and then we're going to talk about photon radiation and a bit beyond. And yeah, so first off, so what is radiation? Well, it's the transfer of energy, transfer of E. What's some other thing? Well, in EM radiation is from EM fields. That would be such as like charges and like currents, like EM fields. Okay, but what about where is it from? Where does radiation come from? Well, it comes from like any change in E of a system. An example of this might be from like an electron change. So like for example, this is like second level, this is first level for like an atom, goes from second to first level, it emits some radiation, essentially. So what are some like sources that we see radiation from? Well, for starters, what allows the Earth to function? Well, the sun, or just stars in general. That's one source of radiation. The sun specifically gives EM, electromagnetic radiation. Another one would be black bodies. This is something that we're going to be talking a lot about, which is like matter at a like finite temp. This is a pretty big concept that we're going to delve further into. To talk more about astrophysics or astronomy, the cosmic microwave background also has radiation. But what about something that is closer to home? Something beneath your feet? The Earth emits radiation. Much of it is like infrared radiation that's emitted back into space. And what's something that's even more close to home? Another source of radiation? Well, humans. Humans emit radiation. Also mostly infrared. So if you had like infrared goggles on, and like the humans and you'll see like a person or an animal, you'll see like them light up. That is because they're releasing infrared radiation. So now what are some ways to characterize radiation? Well, wavelength is one, direction, that's pretty important. Interactions in like matter and such between like atoms or particles. All of that is true, but we're gonna divide this up as we talk more about it. So like macro definitions would be like intensity, which we'll talk more about, and like flux, and a little bit more. And there's some micro elements too, such as like E or like electric or magnetic fields, and some more. So moving on to photons. and beyond. So in this topic, we're going to talk, at least at first, about photons. Much of it's going to be about photons. Some things with photons is that they are massless, so mass equals 0, and they are a direct result from the electromagnetic field. In fact, to talk more about that, photons are gauge bosons. What does that mean? It means that they result from ripples in the magnetic field. So if you imagine kind of like a sheet of the electromagnetic field, as it kind of ripples, it'll create like almost like pockets of like energy. I don't know how the best to describe that for right now. But those ripples essentially make photons. And so photons are like the quote unquote force carriers of electromagnetism. So they are like the force carriers of electromagnetic field. Some other things. Much of the sun, really, mostly, if not like all, is EM radiation. So EM radiation, photons are a direct result from that. Therefore, photons are pretty useful for this. Also, light, for example. Light is made up of photons. Okay, and now that we have that, some other things with photons. The energy of the photons is related to h Planck length times the frequency, and the momentum, because photons are massless, the momentum is only E over c, the energy over the speed of light, which is then equal to this. So one day we will discuss radiation when mass does not equal 0. That might be further in the course, but potentially further in. But anyhow, thank you for watching, and I hope you all have a wonderful day. Let me know if I made any mistakes,